We're going to be doing a little bit of a review today with adding and subtracting like fractions. So when simplifying fractions, let's remember that we divide the numerator and the denominator by the same factor. The simplest form is when no other factor but 1 can divide into both values. That means the number 1. No other factor but the number 1 can be divided into both values. So looking at model number 1, in the model there's 3 out of 15 of those hexagons shaded. So our fraction is 3/15, and simplest form of that we would divide by 3 on top and divide by 3 on the bottom. We get 1/5 for the simplest form of that. Number 2, the model is 6/18, so go ahead and divide to find out what your simplest form will be. Now, changing improper fractions to mixed numbers. We have reviewed this a little bit, but we divide the denominator into the numerator. Okay, so in 8/3 we would divide 3 into 8. How many 3's can I get out of 8? The remainder will be the new numerator. So I can get 2 sets of 3 out of 8. I can get 6 out of there, 2 sets of 3. So that gives me a whole number of 2. And if I'm taking 6 of them out, that would be 8/3 minus 6/3. That would leave me with 2/3 left. So I have 2 and 2/3 left here. The other thing that I could do is actually divide it out. 8 divided by 3. Okay, and that would come out 2 times 6 for a remainder of 2. So my 2 becomes my new numerator. I keep the same denominator, 2 and 2/3. Let's see how many of these we're going to do here. Okay, so I want you to go ahead and do 28/3 on your own. How many, what mixed number would 28/3 make? For changing mixed numbers to improper fractions, you might remember the check method from last year and years past, where you multiply your whole number and your denominator, and then you add the numerator. Okay? And you also might do kind of a counterclockwise thing where you multiply and add here. Start with the denominator, multiply times 4, add 1. Start with the denominator, take 2 times 2 plus 1. Okay? That'd be the check method. All right? Now, so we take 2 times 2 is 4. 4 plus 1 is 5 for the numerator. And keep your denominator of 2. This would also be the same as saying that 2 over 2 is the same as 1. So I'm going to have 2 of those. Okay, and then I have another 1/2. So if I add all these fractions up, this is worth 1, that's worth 1, that's worth 1/2, 2 and 1/2. 1, 2, 3, 4, 5. And our denominator when we add fractions stays the same. So 5/2. Go ahead and use a method of your choice on 4 1/3 to figure out what that improper fraction would be. Now let's talk about adding and subtracting fractions. Remember that you have to have a like denominator, common denominator, and then you combine the numerators, but the denominators stay the same. Now, when we have whole numbers, we can add our whole numbers together on addition, and then add the fractions after that. So for adding fractions, if I want to add these two fractions, I can add the 5 and the 4 together. That gives me 9. And the 1/8 plus 5/8, I'm going to add my numerators to get 6/8, which simplifies down. We can divide by 2 on both the top and the bottom to get 3/4 here. Okay, so I end up with 9 plus 3/4, and that is 9 3/4. Okay, I want you to go ahead and do number 2. You're going to want to be careful on number 2. After you add your fractions, There's nothing here. This would be a 0 in front of this, so it's going to be 19 plus 0. And then 5, 6 plus 5, 6, you'll end up with an improper fraction when you do 5, 6 plus 5, 6. So you're going to have to change that to a mixed number and add it back to the 19. Okay? So for example, if I have 7 and 5/8 plus 2 and 5/8, I'm going to have a total of 9 for a whole number, and then 5/8 plus 5/8 is 10/8 for my fraction. Now, I know this is an improper fraction here, this 10/8. So I can take 1/8 out of here and add it to the 9. So what I'm actually going to have is 9 plus, and that'll be 1 whole plus 2 more 8ths, or 1 1/4. So I'm going to have 9 plus 1 1/4, which will be 10 1/4. Okay, so you're going to end up with an improper fraction on number 2. You're going to have to simplify it into a mixed number and then combine it with your other whole number to get your answer for number 2. Number 3, we're subtracting. Once again, we pretend there's a 0 here. 19 minus 0 is still 19. 5/6 minus 4/6 is 1/6. So we have 19 1/6 here when we subtract. Now on number 4, and let's see what we got coming up here. All right, we got some of this. On number 4, you are going to have to you've got fractions here that we're trying to subtract. We have 1/8 and we're trying to take away 5/8 from it. Well, 1/8 obviously doesn't have 5/8 to take away, and we can't have a negative fraction here. Okay, so we're going to have to do something called borrowing. So this is the example for that one. And I'm going to make an example over here for this one and have you try that number 4 on your own. So if I had 3 1/3 and I want to subtract from that 1 2/3, okay, I could subtract my whole numbers, but when I go to subtract my fractions, I can't take 2/3 away from 1/3. There's not enough of a fraction here to take away 2/3. This number, this numerator, has to be bigger than this numerator in order to subtract. So what I'm going to have to do is I'm going to have to borrow a whole one from this 3 right here. If I wanted to make 3 1/3, I could call it 3/3, that's worth 1, and 3/3, that's worth 2, and 3/3, that's worth 3, and then another 1/3. Okay? So if I take 3 1/3, I can break it down into 3/3 plus 3/3 plus 3/3 plus 1/3 for 3 1/3. So when I don't have enough of a fraction to subtract, I am going to have to borrow one of these big ones here, this 3/3. I'm going to have to borrow this one and add it to this one. So I'm going to combine these two back together. That makes 2 wholes. And then over here, I'm going to have 3/3 and 1/3 to make 4/3 back into an improper fraction. Okay, so what I did was I split up my 3 into individual fractions that are worth 1. And I'm going to borrow one of those fractions and put it with my 1/3 so that I have an improper fraction to subtract with. So now I have 2 4/3 minus 1 2/3. Now I can subtract because my first numerator is bigger than my second numerator. So I'm going to do 2 minus 1 is 1. 4/3 minus 2/3 is 2/3. 4 minus 2 is 2. We keep the same denominator. So my answer would be 1 2/3. All right. I'm going to try another example for you here because I know this is the more difficult concept for subtraction of integers. I'm going to do another example up here. if I have 7 and 5/9 minus 7/9, okay, this numerator is smaller than that one. I'm going to have to borrow one of my whole fractions out of the 7 to make an improper fraction with the 5/9 so that I can subtract 7 from it. So I'm going to take 1 away from 7. I'm going to borrow 1 and make it 6, and I use my denominator, and 9/9 and 5/9. So I took my 7 and I made it into 6 and 9/9. That's the same as 7. But I still have to add that 5/9 back on that I originally had, which will give me 6, and 9 plus 5 is 14/9. Now I can subtract 7/9 from that. And my answer is 6 and 7/9 when I subtract. Okay, so I want you to try number 4 on your own, borrowing from the whole numbers in order to subtract your fractions. Your word problems, I would also like you to try on your own. Okay, you've got an addition word problem with mixed numbers, and then a subtraction word problem with a whole number and a mixed number. So I want you to try those two on your own. When you have a whole number and you're trying to subtract a mixed number from it, you're going to do the same thing. If I had 30 minus 1 and 1/5, I don't have a fraction here to subtract 1/5 from, so I'm going to have to borrow 1 from my 30 and make that 1 into a fraction. So I'd end up with 29 and 5/5. That's the same as 30. And then I can subtract my 1 and 1/5 from it. So I would end up with 28 when I subtract my whole numbers and 4/5. Okay, so that's going to be similar to problem number 6 here. So I want you to go ahead and work that, and we will talk some more about it tomorrow.